Hey guys, this is Mr. Grice for Algebra 2, Unit 2.4 Notes. Today we are going to be talking about solving linear systems of 3 equations. Our learning target today is to be able to solve a 3x3 linear system of equations. So far in this unit we've talked about solving 2x2 systems, meaning you have 2 equations and 2 variables. However, there are systems that can also have a 3x3, meaning it contains 3 equations with 3 variables, dun dun dun. And here we go, this is the x, y, and z coordinate plane. All right, you can see the normal y-axis, which we are also, let me get a bit better color. The y, you can't see anything that I'm highlighting here. Well, there's the y-axis that's going up and down, the x and y axis that's kind of going side to side, and the z axis kind of cuts through all of that. So we've got our 3-dimensional plane going on right here. Now, if you're in class, you missed Miss Carranza doing a very good job of explaining this. So if you'd like her to explain it again, you might have to pay a couple dollars to see the show. So we're just going to be talking about solving systems of equations with 3 variables. So what we're going to be doing now is you need to use elimination twice, okay, 2 times to create a 2x2 system of equations. Now, when you're doing it, you must cancel the same variable, okay? Now, in class, and what we're always going to do first is we're going to cancel the x's, all right? So we have to use elimination twice to cancel the x's. And then we'll have 2 new equations, and then we're going to solve the 2x2 system, and then substitute back in. And then once we're done substituting everything, we'll be able to come back and substitute the 2 values into the 3x3 system. Okay, now, I know you're like, whoa, that's really weird. It's not that bad. Okay, so let's go for it. Now, we're going to start with not example 4, Mr. Grice. We're starting with example number 1. So we have A is our first equation. We have B is our second equation, and C. So the first thing I'm going to look at is A and B. So I'm just going to write those 2 down. So I'm going to write A and B on the top. So we have negative 3x plus 4y plus 2z equals 1. So I'm going to kind of make sure I write that down correctly. So it's plus 2z equals 1. And then we have x plus 2y minus z equals 6. So I need to cancel the x's. So if I'm going to cancel the x's, I need a positive 3 right here. So to get a positive 3 right there, I'm going to multiply everything by positive 3. Now, my top equation stays the same. So I have negative 3x plus 4y plus 2z equals 1. And now we're going to multiply everything by 3. So I've got 3x plus 6y minus 3z equals 18. Just remember, we have to multiply everything. Okay? And what we do is we cancel the x's, which is what we wanted. Now we have 10y. 2 minus 3 would be negative 1z equals 19. Okay? And this is one of our 2x2s. Okay? And since that's one of our 2x2s, I'm going to call this D. Okay, so I did A and B. Now I'm going to cancel B and C. All right, so with B and C, the first thing that we're going to do is I'm going to write everything down again. So I have x plus 2y minus z equals 6. And then on the bottom, we have 2x minus y plus 3z equals 7. Now, you guys might be thinking, oh, I could cancel the z's really easily, or oh, I could cancel the y's. That's not going to help you, okay? Not right now. First step is we have to cancel the x's, okay? So to cancel the x's, I need to multiply the top, and I need to multiply the top by a -2 because I need a -2 to go right there. So multiply by -2, we get -2x minus 4y. Negative times a negative is a positive 2z equals -12. Yeah, don't forget about that last guy. All right, and the bottom equation stayed the same. So I have 2x minus y plus 3z equals 7. And just like we wanted to, the x's cancel. -4 minus 1 is a -5y. 2z plus 3z would be 5z. And then -12 plus 7 is -5. Okay, and now that I've combined those two, I have E. So now that I've done A and B and C, once I cancel D and E, okay, this is the last time I'm going to use elimination, then I'm going to have one of my variables solved for. Okay, so over here, I'm just going to write D and E. We've got 10y minus 1z equals 19. And then we have -5y plus 5z equals -5. Now, you could cancel the x's, or sorry, the y's or the z's. It's whichever one you want. Personally, I think it's easier to cancel out the y's just in this case because all I have to do is multiply by 2. They're already opposites, okay? So when we do that, we get the first equation stays the same, so the 10y minus 1z equals 19. And now I'm multiplying, I get -10y. I get a positive 10z and a -10. Now I cancel the y's, and then -1 plus 10 is 9z. 19 minus 10 is 9. And then when we divide by 9, because the z is all by itself, we get that z equals 1. Okay, now guess what? That's actually, I'm going to highlight that. We're not done yet, okay? I just know z. I still need to find y and x, okay? So I'm going to plug into D or E, okay? I'm going to plug into one of these. It doesn't matter which one. Looking at my notes, I did D, okay? So I've got 10y minus 1, and I'm plugging in 1, equals 19. So we get 10y. -1 times 1 is -1, equals 19. I'll move all this down here so you can see how everything kind of lines up. We're going to add 1 to both sides. And I get 10y equals 20. And when we divide by 10, we get that y equals 2. Okay, so I have z, I have y, but I still need x. So to go back and find x, here we go. I'm coming all the way back here, and I'm going to use b because x is already by itself. Okay, so as I'm typing back into b, all right, I'm going to write the equation down exactly what it says. It's going to be x plus 2 minus 1 equals 6. Okay, The y was 2, the z was 1. So we get x plus 2 times 2 is 4 minus 1 equals 6. So we get x, let's see, 4 minus 1 is 3. So we get x plus 3 equals 6. And then to solve for x, we subtract 3 to both sides, and we get our final answer of x equals 3. Okay, so now that we've done all that work, how do we write our final answer? Well, our final answer is going to be x, comma y, comma z. So it's going to be 3, comma 2, comma 1. And then that is our final answer. Okay? Now, you might be like, oh, Mr. Grice, that was so hard. It's not that bad. Okay? Is it work? I'm not going to argue that it's not work. It's just you have to stay organized. Okay? All right. Let's go ahead and start some of the homework together. So we have A, B, and C. Now remember, the first thing we do is we do A and B. Now, as I'm starting to write these down, the one thing that I like right away, do you know what I like right away? Oh, you probably don't, at least not yet. Remember, we want to cancel the x's. That's right. So, what do you notice right away? Yeah, we really don't have to do that much work, okay? Because the x's are all good, we can cancel those, and then I can combine. So I've got 3y, 2 minus 1 is negative 1z, and that equals negative 1. Okay, so right here, right away, we were able to find D. Sweet, we did that pretty quick. Okay, now we need to do B and C. All right, so I'm going to write down B, negative 3x plus y minus 3z equals 0. And then we have x plus 2y plus z equals 0. And I want to cancel the x's, so I need to multiply by 3 because I want a 3 to go right there. All right, so the top equation stays the same, the negative 3x plus y minus 3z equals 0, and I'm going to multiply by 3. So we get 3x plus 6y plus 3z equals 0. So I'm going to go ahead and my x's cancel. I get 7y, and uh-oh, negative 3 plus 3. What happens to the z's? Yeah, those cancel too. That's like an added bonus. And so we get 7y equals 0. I can solve for y right away, and we find out that y equals 0. So score, we already got one of our answers. All right, now I know that y equals 0. I'm going to plug it into DE. Okay, I'm going to plug it into this guy right here. So I've got 3 times 0 minus 1z equals negative 1. 3 times 0 is 0. So we have negative 1z equals negative 1. And when we divide by negative 1, we get that z equals 1. So I have y, I have z. The next thing I need is x. And I'm going to look to whatever equation is the easiest to plug into. I feel that c is, because the x is already by itself. So we have x plus 2 times 0 plus z equals 0. So we're going to plug in a 0 for y and a 1 for z. Well, 2 times 0 is 0. We have x plus 1 equals 0. And to subtract 1 to both sides, we get that x equals -1. Cool, so I've got all of the variables. Now I can just write them in their ordered pair. So we got -1, 0, 1. Sweet. Now, you cannot just be like, all right, I found that answer, so I know that this one's gotta be -4, 2, 0. I'm done. No. No work, no points. You know the rule. We'll do the last one together too. So we got A, B, and C. The last one was kind of a special case. It doesn't happen here. So we have -x plus 5y plus 5z equals 14, and 2x plus 3y plus z equals -2. So we need to cancel the x's out. What do we have to multiply the top equation by? Yeah, by 2. So I want you to multiply by 2 and then tell me what your new equation is going to be. All right, go ahead and pause the video and good luck. Okay, so you should have gotten 13y plus 11z equals 26. Okay, so now we need to do B and C. So B, we have 2x plus 3y plus z equals -2. And then we have x, oh, and that's where we would almost make a mistake, minus 2y plus z equals -8. Now remember, you cannot be like, the z's would be really easy to cancel. Well, yeah, they would be. However, we need to cancel the same variables, okay? So we need to cancel the x's. I need that to be a -2, so we need to multiply everything by -2. All right, so once again, you guys are on your own. Go ahead and pause the video and figure out what E equals. Okay, and you should have gotten 10y minus, right? 10y minus 1z equals 14, right? Hold on. Hopefully you're not paying too close attention to Mr. Grice right here because I made a mistake. That's supposed to be a 3, Mr. Grice. So this should be a 7. Okay, so 7y minus 1z equals 14. I thought that looked a little weird. Okay, so now that I've got D and E, we've got, so I'm going to write D and E over here. We've got the 13y plus 11z equals 26, and the 7y minus 1z equals 14. Okay, now you get to choose what you want to cancel. Now personally, I think the z's would be the easiest to cancel because all you have to do is multiply the bottom by 11. Okay, and yeah, you're going to get a couple of big numbers here, but that's okay. We've got calculators. So we get 13y plus 11z equals 26. Now, on the bottom, as my calculator starts to warm up, we can do 11 times 7 in our heads, because 11 times 7 is 77y, minus 11z equals 14 times 11, which we get 154. Okay, now our z's cancel. I need 13 plus 77, and we get 90. So we have 90y equals 26 plus 154, and we get 180. Oh, this is going to come out nice. Okay, and when you divide by 90 to both sides, we get that, yeah, y equals 2. Okay, so now that we got y is 2, let's go back and find z. All right, so finding z, I just did the 7y minus 1z equals 14, and we're plugging in a 2. 7 times 2 is 14. Remember, that's minus 1. Oh my gosh, my pen's not working right there. So minus 1z equals 14. So we subtract 14 to both sides. And we get negative 1z equals 0. And you should already know what your answer is right about now, but we divide by negative 1. And 0 divided by anything is 0. Okay. And last part is finding x. I'm going to use that bottom equation. You can kind of see it right there because x is by itself. So we have x minus 2 times 2 plus 0 equals negative 8. So I'm plugging in a 2 there, plugging in a 0 there. So we get x minus 4. I'm just going to cross that 0 out right away. Equals negative 8. And we add 4 to both sides. And then we get that x equals negative 4, just like we said it would. Okay, so the final thing that we've got to do right there is just put them all in order. And that's negative 4, 2, comma 0. Because remember, it goes x, y, and z. Okay, and just like we said, that was the answer. Oh, let's check it off. Okay, so I know that's a lot of work, guys. Organization is the key. Okay, now if you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off for Algebra 2, Unit 2.4 Notes and Practice. Thanks for watching.